In this fourth of 6 videos, we'll try to add our own custom Verilog logic into the existing reference design. Logic will be the APB Blinky that we developed in an example 2 of our Verilog mini series here on YouTube. And you can get the source code on GitHub at this address. So let's get going. First step is to go to my GitHub page, Busted Wing 1, and go to the code, select Control C, minimize, go to Git Bash, go to someplace you like in this case the ICE folder is perfectly good. Git clone, Control V, oops, paste. That was a left click paste. That was a right click paste. And, what's going on with my paste? It's all this terrible stuff before and after. I'll have to fix that. But for now, let's clean it up and hit return. Whoa, big download. Okay, so our example, let's see. And so LS iVerilog. iVerilog is a free open source Verilog simulator that I wanted to show off. I didn't write it. I think Steve Icarus wrote iVerilog. And so I did a few examples. It's a very nice simulator. So LS iVerilog example 2. Let's see. And right here, APB Blinky. That's what we're going to be instantiating if we do a cat. Of APB Blinky, it'll show us the contents of it. And just so we can just see it's here. Here we have an APB interface that will be connected to the processor's APB bus through, I think it's Fabric Interconnect 3, FIC3. And then here is the LED that will drive out, and that should connect to, we will connect that to one of the pins that goes to the LEDs on the Icicle board. All right, and so there we go. That's what we're going to try to do. All right, so let's first of all open up Libero version 2023.1 is what I'm using for the examples that I'll be doing on the Icicle board. And recent projects. Let's go to this let's click on this recent project. Actually, that was just a single click. A single left click on the recent projects. Project that we were working on in part 3 of this video. And you can see the progress bar moving across as we patiently wait. And let's see, download the latest versions. Click on the X. Sure, dismiss X, dismiss, why not? All right, now then, it's coming up here. We've got a lot of stuff. Going here is the design flow. It kind of shows that we've passed everything. This is where we left it off in video 3. So what we want to do is, oh, we've already got it open up here. Say these were closed just for good measure. You could go in and on the design hierarchy, you see this bold guy, which is the top guy, the root, which we define as the root, and you can just click on him, double click on him, double left click, and there's the design. And just to touch on it, if you hit a control and the middle scroll button, that zooms in. If you let go and just scroll without pushing any buttons, that scrolls up, scrolls down. And if you hit the shift key and hold the shift key down, and scroll goes left and right. That's basic movement. You can also use this toolbar here and probably this toolbar here. All right. So here we've got FIC0 peripherals. I don't think we really want it. What we really want is the FIC3 peripherals. Here, if we zoom in here, you can see this is connected to this APB master. Let's right click on that blue wire that we just left clicked on. And then we can go to driver. That's coming out of, let's zoom it out. That's coming out of the MSS wrapper. And so that is the Fabric Interconnect 3 APB initiator. If we double click on this MSS wrapper, let's see if it gives us anything. Ooh, a lot going on here, right? Over on the right-hand side is the outputs, which will mostly be by where the, right there, this FIC3 APB initiator. Click on the wire, right click, go to driver. Let's scroll out. That brings us to the MSS, Icicle MSS, which is the microprocessor subsystem, which has the 5 RISC-V processors. And yeah, it's good stuff. So let's get out of this MSS wrapper. We're not going to do any work on that. And we're going to go back to this MSS. Let's zoom out again. Let's see if we're going to follow this signal here. That's the, no, yeah, FIC3. That's what we want to jump into. So we're going to go into here. And this generator, address generator. All right, this looks promising here. So what we're going to do for now is slight cheat. We're going to steal one of these existing ones here. Let's collect onto him. That goes to PWM, a pulse width modulation. Let's follow that for a second, just to see what harm we're going to be doing. So that's PWM 0. Remember that. We're going to go up to the hierarchy here. Let's zoom down in. Look for PWM 0. Right there. Let's follow that. So control, zoom out. Move my cursor over here. And this M bus PWM. So that's a micro bus, which is it's a fairly common interface that the Icicle has. So we're gonna lose that functionality. We're gonna basically connect this signal up to these LEDs. So that's the plan. Let's go back into um, this, and what we want to do is instantiate our Verilog block. So the first thing I think we want to do is we want to go over to File and import HDL for hardware description language source files. And the hardware description file that we're currently using is Verilog. So how did we get there? Because I didn't announce that. So we went to File, left click, import, no click, slide, left click. We're here. Let's navigate up, 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 here. Double click on ice. Double click on iVerilog examples. Double click on example 2. Those are all the left double clicks. And then double click on appblinkyv.v. All right. And now let's see, we go over and you left click on this plus sign next to user HDL source files. We have this file here called appblinky. You can see that the reference design had all these other HDL hardware description language files. These were all in Verilog as well. Now let's create components and let's see what we want to click on. If we left click on Blinky, right click on Blinky, somehow I want to turn it into a component. How do I do that? I don't quite remember. Left click, right click, delete properties. That's nothing of interest. Maybe if I just take a left click and drag it over here. Nope, that didn't work. Nope. Nope. Open HDL file. Okay, this is my HDL file. All of its glory. Still struggling with what do we make this guy into a component? Added it to the source files. Well, let's check it first. So let's go down. So I've right clicked on the blinky, check HDL. Hey, that's nice. So it succeeded. So it's a good file. Still here. Okay. So click OK. Here it gives a little warning. So let's go down to the left, click on this plus sign. Port ready is not. Redeclaration. Now, aren't they being stinky? Well, let's live with that for now. Now let's. How do we sort of got this. Maybe we go to components. That's design hierarchy. I don't know. I'm struggling here. If I don't come up with something soon, I'll have to probably shut this video down and figure out what the heck I'm trying to do. Um, so what I want is to get this file down into being a component. That's what we're shooting for. Drag, no. Many clicks, no. How about this one? Build hierarchy. Which was a left click on the build hierarchy. Just thinking. Okay. All right. So now it's pulled APB. What window are we? We're in hierarchy here. We still have the user Verilog, so that's the Blinky. But it has put Blinky up into the work area. That's almost promising. So let's right click on that. So that was with a build hierarchy solved that problem. Now we right click on it and create core from HDL. That's what I want to do. So what I did was after the build hierarchy, it pulled the Verilog file up into the work area. And now in the work area, I right click on the APB Blinky block. I go down and I'm sorry, I right click. Did I say I right click on the APB Blinky? I go down and there I left click to create core from HDL. So I'm going to left click. Okay, that's all nice. All right. Would you like to remove any of the parameters or add bus interfaces? And to this, we are actually going to say yes. Because what we want to do is we want to add here a bus interface. We want to add, and then we go up to here and we left click to add a bus interface. And that gives us a list of bus interfaces that we can add. And so let's make this a little bit wider. Left click and drag. And then we want to go down and we want to make an APB bus with slave, and we say OK. And they called it BIF1 from, I think, bus interface 1. Let's double click on this name here, and let's call it Caplocks APB. Underscore and wait. You can pretty much call it anything we want, I believe. So we put it there, and now we've got a lot of signals here. And so we try to mix and match. It's found all of these already. And now what it's missing is a few others. How do we add those others? Map by name. Let's click map by name. Left click. And we want to get this guy oh, now I remember. So here we are. And so we have this little, so these are my signals. The tool is smart enough to figure out that these all lined up. the tool was not smart enough to figure out that P cell X goes to something and P SLG error goes to something. So if we go and we click on this down arrow, it gives us all the choices. So we left click on that down arrow, left click, gives us all the choices of what it could possibly be. And then we got P cell, which is what we want, and we left click on P cell. All right, and there it is. Now then, the other one that was missing was this one here, this error signal. What do we call our error signal? We're going to left click on the down arrow. We got P error. That's what we called it. Now we've mapped the Verilog's signals to one of Polarfire's standard bus signals, which will then be able to be used in the schematic. So click apply with a left click. So I clicked on it. I think it's working. I think it's working. So I don't think it worked. So let's go back to APB underscore. That's what I want to call it. And now I want to left click again. Oh, we'll see what happens here. We're going to left click on apply again. Ah, that is nice. So that apply got this name here, APB endpoint, to replace the BIF1 that was here. Now let's left click on apply again. I think so. That apply did that. I think now everything is set. We just say close. So we're going to left click on close. And now what's it saying? Extracted ports. I think we've added a bus interface. I think we're good to go. So now let's click on left click on OK. And here we are. Now we go back to our FIC3 peripherals. Left click on that to bring that up. And let's now open it over here. So we should be able to find what's it called? APB. It's not there. So it still says user. So let's do this again. Left click. Edit core definition. Okay. All right. I'm going to just drag it over and see what happens. I'm going to left click on this APB Blinky, drag it over, and let it go. And here we have APB Blinky has a nice schematic element, and next to all these other lovely little schematic elements, makes me breathe, say, huh. All right. So what we need to do now is we need to connect the clock, the reset. So let's start with the clock. So we go over, see this P clock? See that clock? It's going everywhere. Let's bring it over. So I'm going to go and I'm going to left click here and hold and drag. Left click, hold, drag. Whoop, whoop. Get it over the clock pin. Plus sign shows up. Let it go. Look at what it did. It just connected him up. And now what we're going to do is we're going to click on this reset signal here. It's reset. I call it reset N. It's close enough. Left click, drag, let it go. It's two things. Now we just got to get this APP interface. And what we said was we are going to remove this PWM from our design. So what we're going to do is we're going to click on this signal name here, which says what, APB slave. We left clicked on it. Now we're going to right click on it. Maybe you just needed to right click. Then we're going to left click on disconnect. And then we're going to go to this point here. We're going to left click and hold down. Left click, left button, hold down. Now we're dragging while holding down. We're bringing it over to here, our APB endpoint. See the plus sign? Let go of the left mouse button. All right. And now all that's left is we've got this signal here. And so I click on the LED name, turns light blue, right click. Just click on the little pin next to the LED. And let's right click on that pin next to the LED. Well, that's better. And here is one where we want to promote to top level. So we're going to left click on promote to top level and zoom. So we left click on this signal here. We shoot it over. And now we have a signal called LED that is leaving this lower level peripherals block. And I believe that's all we need to do. So now what we need to do is go in here and see. Sometimes what you want to do is click on this little double arrow circle. Watch what it does here. Let's zoom out a little bit. There we go. Let's hit this double arrow and watch what it does. It resets the layout. Now, this Arlington block is right along with all those other blocks. Not bad, huh? And now what we want to do is click on, I don't know, let's generate the component. Can't hurt. So I left click on generate component. And so I believe we've just regenerated the FIC3 peripherals. And now we want to go up to the Icicle base design, which is the top. We want to zoom in. And you can see there, it's got this little exclamation mark. That means he's not quite happy. So let's right click on him and left click on update instance. And now the exclamation mark is gone. And here is our LED signal. This is exciting. All right. So now what we've got is these LEDs here, 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 which I assume are going to the LEDs that I'm seeing on the board. So let me just go in and let me run that one signal to all. Actually, let's start with this one. So I left click on this guy, on this LED 0. I right click. See if I really needed to do that. Right click. I think right click was probably just enough. And then I'm going to disconnect. And now I'm going to take this guy and I'm going to left click right here on this base of this blue LED 0. Oh, I did like that. Um, Not quite sure on what's going on with that. I will come back to him at some point. But let's go back to our FIC. We've got a nice little pin here. And let's left click. Left click? Yeah, left click on the pin of the LED here. Right here, see where we are? Left click. That's nice. Let's see if we can find this guy here. A plus sign. Let it go. And so that connected from the LED to the LED. All right. What's not to like? You know what? I'm going to make this very bold. So I'm going to go in and I'm going to go left click, right click, disconnect, right click, disconnect, right click, disconnect. And so I right clicked on each one of those signals, then I left clicked on disconnect, and now LED 0 is connected up to my R output, and LED 1, 2, and 3 are not being driven by anything. So let's make them all blink at the same time, make it really bold so I can't miss it. So I left click on this signal here, which goes to LED 0, which goes to our LED output from the peripheral block. Click on this, drag, get the plus sign. Nice. Now then left click on this wire here, drag it to here, get the plus sign, let it go. Now left click on this LED, drag it with the left click, still holding with the left button so I can do this, and I've got the plus sign, let it go. So now LED 0, 1, 2, and 3 are all connected together. Now let's do this reset layout and see if that puts those all nice together. See what it did. Yeah, so here's what it did. So it connected those all together and and it goes to our LED output, which is connected to our blinky block, which should blink those LEDs at some rate. I forget how much. I think probably it's excessively too fast. Yeah, I'm pretty sure it is excessively too fast because I'd set it up for our simulation. So what do you say we go back to our Verilog file and we go down in and we change our reset value, which makes it turn at every 128 clocks. That's about, and each clock is 10 nanoseconds. So that's about every microsecond that guy will be blinking. That's much too slow. We really want it to be, let's see, back up. So that right there, 100 would be every 10, every microsecond it will change. So now then, well, in microseconds, if we add 2 zeros, 3 zeros, that would be instead of microsecond, it'd be every millisecond. If we add 3 more zeros, that would be every second. I wonder if that math works. Why not? Let's give it a shot and see. So this is a 32-bit value. 32 bits can hold 4 gig, can hold up to a value of 4 gig because it's unsigned. And so what is this value here? Let's see. Okay, 1,000, million, 100 million. So right now we set this to 100 million. We can hold a value up to 4 gig. So we are good to go. 4 gig is 4 billion. All right, so now we've just changed this. Um, so somebody's got to know that, right? Uh, so let's make sure we hit a save. And now if we go into this guy, let's see if it yells at us here. Let's go back to this guy. And let's do this left click. So somewhere in here, I would think we should be able to go down to here. So I click this left click on this plus button, open this, left click on the HDL, right click on the HDL, check the HDL. Everything's succeeded. Okay. And now I really want somebody to be yelling at me saying this needs to be updated. Maybe it's just good to go. We got this guy here with a bunch of X's. Well, that's nice. So maybe let's left click on the build hierarchy. The following data is unsaved. Do you want to save it? I think so. Yes. So I click left click on yes. Should be building some sort of hierarchy. And kind of like that we've got X's. Means somebody's not happy. Um, um, let's go to this guy here. What's he yelling about? Let's generate the design. So I left click on generate design. This little can with a gear. Um, so it seems to like that. Let's build a hierarchy one more time. So I did do this generate, which kind of should have gone through and checked everything to make sure it's okay. So it's building design hierarchy. All right, I think if it takes this, I'm going to believe that our blinky should blink every second and that our LED signal, which is right here. So this is again scrolling with me holding down the control button. Now I'm going to scroll the other way and move my mouse over to this endpoint and then scroll in and you can see all the LEDs are connected. All right. So now we're going to slide over here. Now actually let's do this regenerate again. That's not so bad. And now we're going to go over. We're in the design hierarchy tab. We're going to go to the design flow tab. Left click on design flow. And all of these have warnings saying that it's no longer valid what has happened. And now we are going to scroll down and click on what are we going to click on? We're going to click on double left click on generate bitstream. And then we're going to shut this down, assuming that's going to pass. So it takes about 20 or 25 minutes to do this full synthesis. If we have any errors, we will maybe debug them, come back in with another debug session to show how to fix an error when you get an error. So, but right now, I'm going to double click this, shut it down, and then we can see if we can get a blinkies. Oh, and I probably won't have another video for downloading to the FPGA because that's what we did in the previous video, video 3. So let's left click on this, double left click on generate bitstream. Following was unsaved. Do you want it? Absolutely. And now I'm going to shut it down and come back with the next video. Hopefully my 4 blinkies are blinking nicely.